Okay, so on page 11, we are going to talk about something called factoring. So the idea for today is that we're looking at another format for our quadratic functions. We've talked about standard form, and that's what we see here. We've also talked about vertex form, okay? We also talked about how to swap between the two. So today we're adding in one more format for our quadratic function. For today, our focus is going to be on the mechanics of getting from standard form to what we're going to call factored form. We could also see it called intercept form. The focus for today is just how to get into that format. Tomorrow, we'll talk more in our next lesson about why we care about this format and what it shows us, and then swapping back to standard form or adding in the graphs. But for today, we're just going to focus on this idea of factoring, okay? The mechanics of how this process works. For our factored form, every problem that we look at today, we're going to rewrite from standard form into something that looks like this. And we're going to fill stuff into these little parenthesis groups. These are going to be called our factors. It's kind of reminiscent of vertex form when we wanted to change it back to standard form. So if I had vertex form, let's say our vertex form looks like this. When we wanted to change it back to standard form, we took the thing in parentheses and wrote it twice to distribute. So it's going to look kind of like this, except for nothing at the end. Okay, we aren't adding or subtracting anything at the end. Now, in some cases, the stuff in parentheses could be exactly the same like what we saw here. In many cases, it won't be exactly the same, okay? So what we're gonna talk about today is what that factored form looks like, how I get it to look like that. So for number one, I want you to remember that this middle number we called B when we looked at that last time. Whoever is playing music needs to stop. I can hear it up here, so it's not as quiet as you think it is. Remember when we switched to vertex form, we had that B cut in half? And then that number at the end we called C, that was our constant term, okay? That was our y-intercept. That's what we could see from standard form. So we're using those two numbers today, okay? What we're gonna look for are factors, things that multiply to C, but then add to give me B. So for the first few problems, I'm going to write out all of the factors for each of these C values. So for number 7, it's not too long of a list. To get 7, I could multiply 1 times 7, or -1 times -7. We're only interested in integers. So that would be positive or negative whole numbers, okay? No decimals or fractions, nothing super funky, just positive numbers and negative numbers, integers, right? Whole numbers, no fractions or decimals. So this is my whole list. These are all the things I could multiply, all the integers I could multiply to get 7. What I'm asking you now is which of them, if I change this to a plus sign, would give me 8. 1 plus 7, perfect. 1 plus 7 gives me 8. So those are the factors, that's the pair that I want to pick, okay? Now here's what my factored form is going to look like. I know I need to get x squared. I'm going to split that up into x times x. For every problem that we look at today, our factors are going to start off with x times x. Everything that we're looking at today, I've got just x squared at the front. We'll look at different problems a little bit later on in this unit, but for today, we're always going to have x times x. And then we're going to finish our factors with the numbers that we've chosen here, the ones that fit both those criteria. They multiply to 7, but they add to 8. So since it's +1, I'll have x plus 1, and this was +7, so x plus 7. That's my factored form. That's what we're going to do for today, okay? Every problem that we're looking at today is just like this one. Different numbers, the B and the C will change, but this is the process that I'm looking at. Now, I'm going to show you something here. You can always check your work with factoring, okay? Remember that this is supposed to be describing the same function as our standard form, right? We could swap between vertex and standard form. We can also swap between standard and factored form. That means that if I take this, x plus 1 times x plus 7, right? This is saying multiply these two things. If I multiply that, if I distribute here, I have x squared plus 7x plus 1x plus 7. Combine your like terms. We get x squared plus 8x plus 7. See how that's the same as our original problem? I can double check that I factored correctly by multiplying those back together. If I get the same thing, I know I've done this correctly. Okay. And a little later on, I'll show you another way that you can check your work on these. Questions for me so far? Okay, so we're going to keep going here. Number 2, same idea. I want factors of C that add to B. So I want things that multiply to give me 10. If I added them instead, I would get negative 11. So to get 10, I could do 1 times 10 or negative 1 times negative 10. I could also do 2 times 5 or negative 2 times negative 5. That's it. Those are all the factors of 10. Which of them could I add instead to get negative 11? Negative 1 and negative 10. So my factored form would look like x minus 1, since it was negative 1, and x minus 10, since it was negative 10. Okay, that's my factored form. Let's take a look at our next example. X squared plus x minus 90. So I'm looking for factors of negative 90 that add to 1. I'm going to write out my list again, okay? So for negative 90, this time since we want a negative number, one of my factors needs to be negative, right? Before we were looking at positive numbers, so positive times positive or negative times negative. Here I've got a mix and match situation. So this could be negative 1 times positive 90 or 1 times negative 90. Negative 2 times 45 or 2 times negative 45. Negative 3 times 30 or 3 times negative 30. 4 doesn't work. 90 does not divide evenly by 4, but it does divide evenly by 5. Negative 5 times 18 or 5 times negative 18. Negative 6 times 15 or 6 times negative 15. 7 is not a factor of 90. 8 is not a factor of 90, but 9 is. Negative 9 times 10 or 9 times negative 10. 10 is a factor of 90, but I already have it listed. So once I run into numbers that are already listed, we can stop because we've got our whole list. Now, before we continue with this problem, I want to point out I made a list of factors and I went in order. 1 times what, 2 times what, 3 times what. I skipped anything that didn't work, but I went in order. As we're working on some of these problems, some of you will notice that, hey, I thought of these factors that I needed right away, and that's great. The more we practice this, the easier it's going to get. We'll also run into some problems where I'm going to make a list because that's what I need to do to be able to see the factors that I need, okay? Anytime that you're making a list to see your factors, go in order. It's very easy to skip stuff, and you always end up skipping the one that you need, okay? So go in order if you're making a list. Now, from my list, I want the factors that will add to positive 1. What do I want to use here? Negative 9 and positive 10. That would add to positive 1. So my factored form there is x minus 9 times x plus 10. How about number 4? Factors of negative 12 that would add to positive 4. What factors do we want here? Negative 2 times positive 6. That would multiply to give me negative 12. If I added them instead, I would get 4. Those are the ones that I want. So this would be x minus 2 times x plus 6 for my factored form. Very good. Let's take a look at number 5. I need factors of 9 that add to negative 10. Go ahead. Negative 9 times negative 1 are factors of 9, things that multiply to 9, but add to give me negative 10. So my factored form here would be x minus 9 times x minus 1. This is our goal, to get that factored form. Let's take a look at 6. What multiplies to give me 64, but would add to give me 16? Multiplies to give me 64, but would add to give me 16. Positive 8 times positive 8 would multiply to give me 64. When I add them, I get 16. So this would be x plus 8 times x plus 8. So for this example, my stuff in parentheses was the same, kind of like we saw for our vertex form problems. Okay, but this is our factored form. Number 7, factors of negative 24 that would add to give me positive 2. Factors of negative 24. Negative 4 times positive 6 gives me negative 24. If I add those numbers instead, I would get positive 2. Very good. This is x minus 4 times x plus 6. Number 8, factors of positive 24 that I could add to give me negative 4. Factors of positive 24. If I add them, I get negative 4. Who feels a little stumped on this one? Okay, so let's make a list. This could be 1 times 24, or negative 1 times negative 24. 2 times 12, or negative 2 times negative 12. 3 times 8, or negative 3 times negative 8. 4 times 6, or negative 4 times negative 6. 5 doesn't work. 6 does, but I already have it in the list. So these are all my factors for positive 24. Now, I want to add to get negative 4. So it's not going to be any of the positive stuff. What about anything from the negative list? Does that work? Nothing in there is going to add to give me negative 4, right? Okay. So this is an example of a quadratic that doesn't have integer factors. So when we run into that, we're going to write no integer factors. No integer factors. Now, what may be the case here is that I could factor this if I use decimals or fractions. It may be the case that I could factor this if we use irrational numbers or imaginary numbers, but that's not something that we're going to worry about in Algebra 1. Okay, we are just worried about integer factors in Algebra 1. Okay, so if you run into a case like this, you've checked all possible factors and nothing will work, you're going to tell me no integer factors. Now, I'm not going to give you a lot of problems like this. This doesn't help you learn how to factor, so you won't see a bunch of problems like this. So as you're working through homework or practice problems, if you're writing no integer factors for like half of them, go back, try them again, because these are going to be few and far between. I want you to know that that's a thing, but most of the work that we do, you'll be able to factor, okay? Let's take a look at number 9. I want factors of 40 that would add to negative 13. Factors of 40 that would give me negative 13. Negative 5 and negative 8. That would do it. So this is x minus 5 times x minus 8. And then our last problem on page 15, I need numbers that would multiply to give me 18, but add to give me 11. Factors of 18 that add to 11. Yeah, 9 times 2, that would do it. Multiply to 18, but add to 11. So this would be x plus 9 times x plus 2. Very good. Now, I want to show you another way that you can check your work on this. When we were looking at swapping between standard form and vertex form, I showed you how you could use your calculators to check with the graphs that you had done that swap correctly, you had done that rewrite correctly. So I want to show you the same thing with number 1. We already checked number 1 with distribution, so let's check it with a graph as well. I'm going to pull up my calculator here, and we'll take a look at the graph for this thing. So I'm going to start, let me hit the tab key. I'm going to start by graphing the problem that I already had on my paper, which was standard form. So I had x squared plus 8x plus 7. Okay, so there's the graph of my original problem. And now let me graph the factored form that we got. So that was x plus 7 times x plus 1. See how it just looks like the same graph? Okay, that means that they're lined up perfectly. And if they're lined up perfectly, it's the same function. That's what I want. Now I want to show you one more thing that's kind of a preview for what we're going to see tomorrow. Let me move this out of the way. I'm going to show the x-intercepts for this graph. Your calculator calls them zeros, remember? Oops. Okay. And then let me find the other one. So our factored form was x plus 7 and x plus 1. Our x-intercepts are negative 7 and negative 1. Anybody think that that's a coincidence? Yeah. So what we're going to talk about tomorrow is what factored form shows us. Why do I bother with this? Why is it important? So we know standard form shows us the y-intercept, vertex form shows us the vertex. We get some other important information from factored form, and that's what we're going to take a look at tomorrow. Why do we care about this? What does it tell us? Okay. I would like you now to try problems 11 through 15 on the next page. So turn to page 16, try problems 11 through 15. Remember, if you're having trouble finding the factors that you want, make a list. 1 times what, 2 times what, 3 times what. Okay, let's take a look at these. For number 11, I want factors of negative 56 that add to negative 1. 7 times negative 8. Okay. Multiply, oops, forgot my negative there. Multiply and I get negative 56. Add and I would get negative 1. Anytime my number here is small, that's a hint that my positive and negative number will probably be close together. Okay. So this is x plus 7 times x minus 8. How about 12 factors of 6 that add to negative 5? Very good. Negative 2 times negative 3. Negative 3 times negative 2, same thing. Now this one's tricky. I have a lot of people that want to tell me we should use negative 6 and 1. What's wrong with using negative 6 and 1? Why is it not negative 6 and 1? It adds to negative 5. Yeah, because this multiplies to negative 6. Okay. So many people, if I give you this problem, will factor it this way. I gave it to you and I bring it up because I don't want you to make that same mistake. So this would be x minus 2 times x minus 3. Number 13, factors of 8 that add to negative 6. What multiplies to give me 8, but would add to negative 6?
I had negative 4.
Negative 4 times negative 2, that will work. This is x minus 4 times x minus 2. I also want to note that I've been jotting down numbers in the order that you guys have said them to me. If on your own paper you had negative 2 times negative 4 and you wrote x minus 2 times x minus 4, this is the same thing. Okay, as long as you have the same factors, you're good. If the order is swapped, that's the same thing. For 14, factors of 8 that add to positive 6. I want to add to positive 6 this time. Positive 2 times positive 4. So this would be x plus 2 times x plus 4. Number 15, factors of negative 90 that add to negative 1. X plus 9 times X minus 10. So 9 times negative 10 would multiply to give me negative 90, but add to give me negative 1. Very good. Questions for me so far? How many people are ahead of number 15? You got done with number 15 and you kept going. Okay. If you're ahead of me, that's fine. Check your problems as we go. We're going to work through the rest of these. We have a couple sort of special case problems that we're going to see as we get towards the end here. Number 16, I want factors of 10 that add to 11. Factors of 10 that add to 11. 10 times 1. So this is X plus 10 times X plus 1. Number 17, I want factors of 30 that add to 11. I'm going to go ahead and write out the list on this one, and then we'll pick. I haven't written out the factor list in a little while. And this is our first day doing this, so I would anticipate several of us probably still need to write out that factor list, and that's just fine. So to get 30, I could do 1 times 30, or negative 1 times negative 30. I could do 2 times 15, or negative 2 times negative 15. 3 times 10, or negative 3 times negative 10. 4 doesn't work. 4 divided by 30 is not, or 30 divided by 4 is not a whole number, so I can't use 4. But I can use 5. 5 times 6 works, or negative 5 times negative 6. Which of these is going to give me 11? 5 and 6 would add to 11, so I want to pick 5 and 6. My factored form then looks like X plus 5 times X plus 6. For number 18, I want factors of negative 2 that would add to positive 1. So for negative 2, that's negative 1 times positive 2, or 1 times negative 2. I want that first option, since if I added those numbers, I would get positive 1. So my factored form is X minus 1 times X plus 2. Number 19 is a little different. What's different about number 19 from everything that we've seen so far? That middle term is missing, right? I don't have that B. So to start, I want us to think of this problem this way. And then we'll talk about another option that we have. So if that middle term is gone, it means that I had 0 x's. That's the only reason I wouldn't have to write it. We know from several of our examples that if I've got 1 x, I need to still write the x. But if I had 0 of them, I wouldn't have to write that. So what we're looking for are factors of negative 16 that would add to 0. I'm going to write out my factor list again. So this would be negative 1 times positive 16, or 1 times negative 16. Negative 2 times 8, or 2 times negative 8. 3 doesn't work. 4 works. Negative 4 times positive 4, or positive 4 times negative 4, but that's the same thing as what we already have here. So which of these would add to 0? Negative 4 and positive 4. So my factored form here would be X minus 4 times X plus 4. Now, there is a little bit faster way to think about problems like this. You can think of it sort of like a shortcut. What we've got here is something called the difference of squares. So remember, difference means subtraction, just like sum means add. So when I've got the difference of 2 things, and they're what we call perfect squares, that just means a number that has a nice square root. A perfect square is a number with a nice square root. We have a sort of, again, shortcut way that we can think about this. So this is just x that's been squared. And 16 is 4 that's been squared. That's why 16 is a perfect square, right? Square root is 4. That's an easier way to think about it. Then my factored form, I know x goes at the front of each factor, but 4 will go at the back of each factor. I'm adding in 1, I'm subtracting in the other. Another way that you can approach these difference of squares problems. Let's take a look at number 20 now. This is back to that format that we've worked with so much for today. I want factors of -10 that add to -3. What numbers do I want? Factors of -10 that add to -3. -5 times +2. That gives me x minus 5 times x plus 2. For 21, I want factors of -20 that add to -1. -5 times +4. So this is x minus 5 times x plus 4. And now 22 is that goofy thing again that's missing the middle. So I'm going to do that difference of squares kind of shortcut or pattern here. So this guy is just x that I squared. What would I square to get 36? 6. So this is x plus 6 times x minus 6. Let me give you one more of these. Let's say I have x squared minus 25. Yep. This would be 5 that I squared. That first guy is just x that I squared. So this would be x plus 5 times x minus 5. Questions for me for today? Okay. You do have an assignment on Delta Math for tonight. You have a few problems where I'm asking you to practice that difference of squares pattern, and then some problems that are a little more similar to the rest of the work that we've done today.